Hey everybody, so this is the first video in my series on connected particles with friction and inclined planes. So in example 1, we're told that a block of mass 15 kilograms rests on a plane neither inclined at 30 degrees to a horizontal. It is connected by a light inextensible string that passes over a smooth pulley, neither attached to the top of a plane, to another block of mass 10 kilograms that is hanging freely. And the frictional force exerted by the plane on the block is 2.4 newtons. We've been asked to find the acceleration of the blocks and the tension in the string. Okay, so with questions like this, the best thing we can do is to start labeling our forces. We know this 15 kilogram block will have a component of weight, and this will act vertically downwards. It'll be a product of mass and the acceleration due to gravity, so 15g. And this weight will have a component which is perpendicular to the plane, acting through the plane, when its angle is 30 degrees, the same as this one. And this will be 15g cos of 30. It will also have another component which is acting down and parallel to the plane, and this will be 15g sine of 30. And we're told in the question that the frictional force exerted is 2.4 newtons between the plane and the block. And as the block is moving up the plane, friction will act against it, trying to slow it down. So friction will act in this direction. And we're told this is 2.4 newtons. And we know there'll be a normal reaction between the plane and the block, which we can call RA. Okay? And if we look at the 10 kilogram mass, well, this will have another weight, acting vertically downwards, of 10g. And because it's hanging freely, there'll be no other forces acting on this other than this tension. So we told him the question is connected by a light inextensible string. So this means this acceleration will be equal to this acceleration because the string is inextensible, which means it doesn't stretch. So the next step would be to resolve the forces up and parallel to the plane, because this is the direction of the acceleration. So we can see that the tension is opposed by the friction and the component parallel due to the weight. So we can say tension minus the sum of the opposing forces, so 2.4 plus 15g sine 30, will have a net force of a mass times the acceleration. We can work out this bit on our calculators. So we'll have 2.4 plus 15 times g times the sine of 30. And this is 75.9. So tension minus the 75.9 will equal 15a. Now I can't really go any further with this because we've got two unknowns. But because we've got two unknowns, we need two equations. We can find the other equation by resolving vertically for this object. So if we resolve vertically downwards, I've chosen downwards because this is the direction of its acceleration, then the 10g minus the tension, you can see 10g is going down, tension is going up. This will have a net force of 10 times the acceleration. So here's my second equation. Now to solve these simultaneously, I need to line up the coefficients. So we call this equation 1. We'll move this 15a to the left-hand side and this constant to the right-hand side. So we'll get 10 minus 15a will equal 75.9. And with equation 2, we'll move this negative t to the right-hand side and we'll keep the 10g here. So we've got tension plus the 10a will equal 10g, which is 98. Then we can solve these two using our calculators. So if we put in our coefficients, tension's got a coefficient of 1, the acceleration is negative 15, and the constant is 75.9. For equation 2, coefficient of 1, 10, and 98. So we can see that the tension is 89.16 newtons and the acceleration 0.884 meters per second squared. Okay?